A quick lesson on something called completing the square. Here's a trinomial, and we want to turn it into a squared binomial plus or minus a number. I'll show you what that means. The first thing you have to do to complete the square is you have to do a trick from kindergarten, which is the fact that adding 0 to something doesn't change that number. So I've added a 0 here. Strange as that seems, follow me on this. Then you change your 0 into another version of 0. For example, 9 minus 9 is 0, another fact from kindergarten. Now, why did we choose 9 minus 9 here and not 7 minus 7 or 2 minus 2 or other options? That will be revealed later in this video. But for now, let's all agree that 9 minus 9 is 0. Because I've chosen that as my 0, I can now factor the first three terms into what's called a perfect square. You'll notice, if you remember factoring, that this thing, trinomial, factors into a binomial times itself, also known as a perfect square. So I can replace that in my problem. Then, combining the final two constants, I can get my constant in my answer, and that is the process of completing the square. The original problem is called standard form. The so-called answer is called completed square form. But of course, this leaves a looming question. Why did we choose 9 minus 9 as our, quote, 0? Watch what would happen if we chose something else. I think we can all agree that 5 minus 5 is 0. It turns out to be a bad choice for 0. Watch why. By choosing that, I could factor these terms, notice the green, but factoring them wouldn't give me a binomial times itself. I could go about this far, but I would never turn this into a perfect square. Is this all valid math that you see in front of you? Absolutely. Is it useful? Maybe, but not if we want a so-called completed square. So let's go back to the original problem and analyze why it is that we chose 9 minus 9, or what it is we could have done to find out that 9 minus 9 was our 0. What you can do here is you can take the so-called linear coefficient, the 6th, and you can do a completing the square trick where you divide it by 2 and then square that result. 6 divided by 2 is 3, 3 squared is 9, and therefore I wanted to make my 0 using a plus 9, which of course turns it into 9 minus 9, which makes 0. And once you've chosen that, everything else will work out as I showed you before. Now the linear coefficient is most of the time either going to be 2, 4, 6, 8, or 10. And I've made a little table here of zeros you can use in each of those cases if you don't want to use the divide by 2 and square rule.